Hi everyone, here are your Algebra 2B questions on lesson 94A. I've listed the questions that were asked on the YouTube comments, and I will start on number 1. Number 1 says use the relationship PV equals nRT to find the number of moles in a quantity of an ideal gas when the temperature is 473, the pressure is 2, and the volume is 10 liters. Remember that R is equal to 0.0821. Begin by solving the abstract equation for N. So I am starting with the equation PV equals nRT. And it says the first thing that you need to do is to solve this equation for N. So I'm going to start by dividing both sides by RT, which means that my equation is now going to be N is equal to PV over RT. Now P is the pressure, V is the volume, R is going to be that standard number 0.0821, and then T is the temperature. So the pressure that we are given is 2, and the volume is 10. So 2 and 10 go in the numerator. And in the denominator, we know that our R is 0.0821, and then our temperature is 473. And all you need to do is plug that into your calculator. So that would be 20 divided by, and then I have to put this in parentheses, so 0.0821 times 473 and the parentheses equals, and my answer is going to be 0.52. And that's the number of moles that we were solving for. Okay, next we're going to move on to number 3. So the Susie Q could go 48 miles downstream in the same time that it took her to go 32 miles upstream. If her speed was 10 miles per hour in still water, what was the speed of the current? All right, so we have the Susie Q, which is going to be our boat, and it says that it could travel 48 miles downstream. So the distance downstream is going to be 48. In the same time it took her to go 32 miles upstream. So the distance upstream is 32. And it says that the times are equal, so the time down is equal to the time up. And it says that her speed was 10 miles per hour in still water. So the boat speed is 10. And we are trying to solve for what W is equal to. Now, I have two equations that I need to know for this problem. The downstream equation, which is going to be B plus W times TD equals DD. And then my upstream equation, which is going to be B minus W times TU equals DU. Now what I'm going to do is I'm going to plug in the information that I know. I know that B is equal to 10. So this would be 10 plus W. I'm going to change my TD to TU and my DD to 48. I'm going to distribute the TU. So I get 10 TU plus WTU equals 48. Now I'm going to work on this side of the equation. I know that B is equal to 10, so that would be 10 minus W times TU equals 32. Do the same thing and distribute the TU. So I get 10 TU minus WTU equals 32. Now I have two equations that both contain WTU, and one of them is positive and one of them is negative. So if I were to add these two equations together, the WTU is actually going to cancel. So I would have 20 TU, 32 plus 48 would give us 80. which means that TU is equal to 4. But we actually want to solve for the speed of the boat. So what we're going to do is we're going to take that TU is equal to 4 and plug it into we're solving for the speed of the current, so the W. I'm going to take that TU and plug it into this equation here. So that would be 10 times 4 plus W times 4 equals 48. I know that 10 times 4 is 40, so I'm going to subtract 40 from both sides. So I have 4 times the speed of the current is equal to 8, and therefore the speed of the current, or W, is equal to 2. And that would be your answer. Okay, now we're going to move on to number 8. So for number 8, they ask us, use the discriminant to determine the kinds of numbers that will satisfy the equation negative x squared plus 4x plus 4. Do not solve. Okay, so remember, if we go back to our notes from lesson 93, these are the things that we know. If b squared minus 4ac is equal to 0, the solution is one real number. Then if it equals a positive number, there are two real number solutions. And then if it equals a negative number, the equation has two complex solutions. So that's what I'm trying to do, is I need to determine what my b squared minus 4ac is equal to. And to do that, I'm going to start by setting this equation equal to 0. So I'm going to move the x squared to the other side, which would give me 0x squared plus 4x plus 4. So now I have my a, I have my b, and I have my c. And I'm looking for just the b squared minus 4ac portion. So my b squared would be 4 squared minus 4 times a times c. So I actually have 4 squared, which is 16, minus 4 times 1 times 4, which is actually 16. So 16 minus 16 is going to be 0. Now I go to my chart and it says that if b squared minus 4ac is equal to 0, the solution is one real number. So my answer is going to be, there's going to be one real number solution. And that's your answer. Okay, so you need to make sure you have your notes too for your lessons. Okay, so now we're going to look at number 9. Before I can do number 9, I have to graph. So I need to set this equation equal to y. So the first thing I'm going to do for this one is I am going to move the 2x to the other side. So that would be 3y is greater than negative 2x minus 6. Then I'm going to divide by 3. Should give me y is greater than negative 2/3 x minus 2. Now I'm going to do this other one down here. So this would be negative 3y is greater than or equal to negative x minus 6. Then I'm going to divide by negative 3. And remember, when you divide by negative, it flips the sign. So this is going to become y is less than or equal to positive 1/3 x plus 2. So remember, when you divide by a negative, it flips the sign. So now I need to look at my two lines. I have this line here, and then I have this line here. This one is greater than, which means that I'm going to shade everything above the line. And because there's no equal sign underneath it, it's going to be a dotted line. This one, because y is less than, that means I'm going to shade everything below it. And because there's an equal sign, it's going to be a solid line. And now I need to graph this. One, two, three, four, five. 1, 2, 3, 4, 5. Okay, so now this first line is going to cross at negative 2. So that means from the origin, I'm going to go down 2. Then my slope is going to be down 2, 1, 2, over 3, 1, 2, 3. Or up 2 over 1, 2, 3. And remember that this is going to be a dotted line. So I'm going to connect these points with a dotted line. Okay. And then for the second one, I'm going to cross out positive 2, and my slope is going to be positive 1 over 1, 2, 3, or down 1 over 1, 2, 3. And this one's going to be a solid line. Okay. And then when we're going to be shading, for the first one, I'm going to shade everything above the dotted line. So that would be all of this region here, above the dotted line. And then I'm going to shade everything below the solid line. But remember, your answer is just going to be the portion that's shaded by both. So on this one, it's going to be the portion that's below the solid line but above the dotted line. And that would be your answer. Now moving on, we're going to look at number 10. So the first thing I'm going to do for number 10 is that I need to get the x by itself. But I also know that because there's a slash through this inequality sign, I'm going to have to flip that inequality sign. And because there's no equal sign, I'm going to add one in. So everything else is going to stay the same at negative x plus 3 is greater than or equal to negative 2. Then I'm going to move the 3 to the other side, subtracting it. So that would be negative x is greater than or equal to negative 5. But then I need to divide this by negative 1. And when I do that, that flips my inequality sign. So this is going to become x is less than or equal to positive 5. Now I'm going to work on the other side. I'm going to move the 3 to the other side, and that would give us negative x is less than negative 8. But then just like on the last one, I have to divide off that minus sign, so I'm going to divide it by negative 1, but that also flips my sign, so it becomes x is greater than 8. My domain is integers, so remember integers are points, not a line, or a dot with a line. So I'm going to draw my number line. So I have 3, 4, 5. So here's my number line. My dot on 5 is going to be filled in because it is x is going to be less than or equal to 5. And then on 8, it's going to be open. Now I'm going to fill in all the points to the left of 5 because it's less than 5. And then for 8, I'm going to fill in all the points to the right of 8. So your number line should look like that. Now moving on, we're going to look at number 11. So for number 11, I need to add the two equations together and eliminate one of the letters. And it doesn't matter which one you eliminate. You can decide which one you're going to eliminate. I'm going to choose to eliminate z this time. So when I add these two equations together, I'm going to get 3x plus y equals 4. If I look at my bottom two equations, if I want to eliminate z again, I'm going to multiply this one, the middle equation, by negative 2. So my middle equation is going to turn into negative 4x plus 2y minus 2z equals negative 4. My bottom equation is going to stay the same at 3x minus y plus 2z equals 4. Now when I do that, the z's are going to cancel. I'm going to be left with negative x plus y is equal to 0. Well, if I look at that, if I move this x to the other side, I add it to the other side, I have y is equal to x. So now I can come back to this equation here and replace my y with an x. So this would become 3x plus x equals 4. So now I have 4x equals 4. And therefore, x is going to be equal to 1. Now, if y is equal to x, then I know that y is also going to be equal to 1. And now all I'm left to solve for is for z. So what I'm going to do is I'm going to take these x and y and plug it into any one of these equations to solve for z. I'm going to plug it into the top equation. So 1 plus 2 times 1 minus z equals 2. So I have 1 plus 2 would give me 3. So when I move it to the other side, that would be minus 3. And that would give me negative z is equal to negative 1. So therefore, z is also equal to positive 1. So eliminate one of your variables on both equations, or when you're adding two equations together, and then do it again for the next, and then you can do it by substitution or elimination. Moving on to number 12. So for number 12, the first thing that I'm going to do is I'm going to solve for x in this bottom equation. So x is going to be equal to 2 plus y. Now I'm going to take that and I'm going to plug it into this equation here, and that would give me 2 plus y squared plus y squared is equal to 3. Now I'm going to multiply this out, so this is going to become 4 plus 4y plus y squared minus 3 equals 0, because we're going to solve, we want to set the equation equal to 0. When I add the y squareds together, I get 2y squared plus 4y, and then I have 4 minus 3, which would be 1. And now I'm going to solve using quadratic formula. So it's going to be y is equal to, this is my a, this is my b, and this is my c. Y is equal to negative b plus or minus the square root, b squared minus 4 times 2 times 1 all over 2 times 2. So now this would become negative 4 over 4 plus or minus, and this would become 16 minus 8, which would just be 8. So the square root of 8 over 4, and square root of 8 is 2 root 2. So this would simplify to y is equal to negative 1 plus or minus root 2 over 2. Now, we're going to solve for what x is equal to. So x is equal to 2 plus negative 1 plus or minus root 2 over 2. And the two things you can combine are the 2 and the negative 1. And that would just give us x is equal to positive 1 plus or minus the square root of 2 over 2. And that concludes your questions on lesson 94A. I hope you guys all have a great day. Bye.